Okay. So, I hope you are understanding all this. Things are simple, but just try to understand, not here your what you call not much mathematics is there, but before that you you have to understand all these things, right. So, similarly when branch number, say when branch number j j is equal to 3, right. So, what will happen here, already for j j is equal to 1 and 2 I have told you. So, I think you have understood now. Okay, once more I am telling, when j j is equal to 3, you have to read all this data, you have to read all this data, right. So, when j j is equal to 3 branch number, your m 1 will be equal to I s j j, that is I s 3 will be equal to 3, that is ascending end side for branch 3, and m 2 is equal to I r j j. So, m 2 will be equal to I r 3 is equal to your 4. That means, when j j is equal to 3, that is branch number 3, m 1 will be equal to I s j j is equal to I s 3, because j j is equal to 3, that is equal to 3. So, this is 3, and m 2, that is the receiving end node, that is your I s I r j j is equal to I r 3, and that is equal to 4. So, receiving end node will be 4, and beyond branch 3 how many nodes are there. So, this is beyond branch 3. So, how many nodes are there? If you look, just count 1 2 3 4 5. So, here it is 5 total nodes, and how many, what are the nodes number? 4 5 6 7 8. So, node number are 4 5 6 7 8. This is a main feeder simple case. When you will take radial branches, things will be different. At that time you will see how simple it is. Similarly, for branch 4, it is branch 4 is 4 to 5, right. Branch 4 it is this one, right. So, sending end is branch 4 is your sending end node is 4, receiving end node is 5. So, 4 5, and total number of nodes beyond these branches, node numbers are 5 6 7 8. So, 5 beyond this branch it is 5 6 7 8, right, and total nodes are 4. Similarly, for branch 5, branch 6, branch 7, right. Branch 5, for branch 5 this is sending end node, this is receiving end node. For branch 6 this will be sending end node, this will be receiving end node. For branch 7 this will be sending end node, this will be receiving end node, right. So, this way you first complete this table, branch number, sending end node, I s j j we are writing m 1 is equal to I s j j, but you have to read j j, I s j j, then I r j j, nodes beyond branch j j, this one also, and total number of nodes n j j beyond branch j j. All these things first you have to make the table, right. This data you have to, your what you call, you have to mark your number the network, and all branch number, sending end, receiving end, everything, and accordingly you have to prepare the table, right. This data you have to feed it to the computer, you have to read all these things, but the procedure, right, it is not Newton-Raphson or Gauss serial, right. So, first you have to make this data preparation is simple. Next is your impedance of the branch. These are all given, branch 1, branch 2 R 1 plus j x 1, R 2 plus j x 2, and so on, these are given. So, this is actually impedance, we are putting z 1 is equal to R 1 plus j x 1, z 2 R 2 plus j x 2, and so on. There are 7 branches, because there are 8 nodes. So, 7 branches, z 7 is R 7 plus j x 7, right. Now, if you consider branch 1, the receiving end node voltage can be written as, consider this branch 1, right. Similarly, branch 1, if you look at the table, branch 1 sending end node, receiving end node, right, but from the diagram it is sending end node, this is branch 1, right. V 2 will be V 1 minus I 1 into Z 1, because Z 1 is equal to R 1 plus X 1. So, V 2 will be V 1, I told you V 2 and your suffix 2 and bracket V 2 all are same, Z everything is same. Here I am writing for easy writing, that is why Z 1, Z 2 this way writing, but everything remains same, right. All I told you, Z 1 actually same thing, this Z 1 means Z bracket 1 same thing, Z 2 means Z bracket 2 same thing, right. But this I put it because coding, for the coding, when I was writing making this slide note, I was thinking from the coding point of view, such that it will be very easy for you to understand, right. So, V 2 will be equal to V 1 minus I 1 Z 1, because this is the current flowing through this branch I 1. So, V 2 will be V 1 minus. So, V 2 is known now, because V 1 is known, V1 is known, and say for later I will see how to compute initial values of I1, but for the sake of your what you call understanding, you assume that I1 is known to you, right. Therefore, V2 is, because Z impedance is known for the line, right. Therefore, V2 V1 minus I1 J. Suppose if I1 is known, Z1 is also known, V1 is the slack bus voltage known, so V2 is known. Similarly, for branch 2, you can write V3 is equal to V2 minus I2 Z2. So, here because V2 is known here, so V2 will come here. We assume all I1, I2, I3, I4, I5, I6 all are known. You assume they all are known. How to compute initial values of I will come later, but you assume they are known, say. Therefore, V3 is equal to V2 minus I2 Z2, right. Similarly, V4 will be V3 minus I3 Z3 and so on, because this is a your what you call, this is a main feeder and recursive type of relationship. Similarly, V5 is equal to V4 minus I4 Z4, V6 is equal to V5 minus I5 Z, all equation numbers have been given. V7 is equal to V6 minus I6 Z6, and V8 is equal to V7 minus I7 Z7. Once V2 is computed, substitute here V3 is evaluated, because these are known, we are assuming these are known, right. So, when V3 is computed, these are known, so V4 will be computed and so on. But before computing this V1, V2 is equal to V1 minus I1 Z1, this initial value of I1 we have to compute I1, I2, I3, I4, I5, I6, I7. These initial values we have to compute before we compute this your V2, V3. But for your understanding, first I am writing this equation. After that I will show you how to compute this thing, but in code when you write this initial values of I1, I2, I3 all capital I values you have to compute before computing these equations, right. As you have 7 equations, that is why in general if last node is 8, it would have been VNB is equal to VNB minus 1 and INB minus 1, then ZNB minus 1, right. But anyway, as all nodes are there, we have taken like this. So, this I1, I2, I3 we have to compute, right. Once this is done, I mean these equations are written, next one is that just for your the other, I will make some matrix form rather than directly, because we have main feeder plus main feeder with lateral branches, we will come to that how to get the solution, right. Substation voltage V was known. So, if I was is known, that means if we know this I1, I2 everything, but for the first branch if I1 is known, say, right, that is current of branch 1, it is easy to compute V2 from equation 1. That means from equation 1 V2 can be easily computed, because if I1 is known, right. Similarly, once V2 is known, it is if V2 is known, easy to calculate V3 if I2 is known, because Z impedances are known for you, right. So, therefore, voltages similarly voltages of node 4, 5 up to node NB, in this case total number of node NB is equal to 8. For this example, I mean the diagram whatever you have taken, we have 8 nodes. So, NB is equal to 8 can easily be calculated if all the branch currents are known, right. Therefore, a generalized equation of receiving end voltage, sending end voltage, branch current and branch impedance is, therefore, we have to write a generalized equation. So, generalized equation will be Vm2 is equal to Vm1 minus Ijj Zjj, right, but Ijj is not computed yet, we have to do, but how we will do it when we write the code, right, like for Jj is equal to 1 to Ln, Ln is the total number of branches, that means Ln actually is equal to Nb minus 1, right, Nb is the total number of nodes. So, branch number will be 1 less, so it will be Nb minus 1. For Jj is equal to 1 Ln, then what you define? You define M1 is equal to sending end node ISJJ, and you define M2 is equal to IRJJ, right. After that you write Vm2 is equal to Vm1 minus your Ijj into Zjj and end, right. So, because this table you are reading, this table whatever we have made, this table all branch number, sending end node, receiving end node, node 0 branch Jj and total number of nodes, all you are reading as a data. This also will be required later, but M1 is ISJJ, M2 all these things are reading. So, when you write code or something, you write for Jj is equal to 1 to Ln, then put M1 is equal to sending end node ISJJ, automatically after reading this it will take, those who are writing code you know it will take, and M2 is equal to IRJJ, then you write Vm2 is equal to Vm1 minus Ijj into Zjj, this is end. So, this is automatically all the your receiving end voltages for each branch will be computed. This is only 1, 2, 3, 4 lines only, 5 lines if you write the code and your what you call you read those data. So, that means here in that here I have not written there here, right. So, here I am writing only Vm2 is equal to Vm1 minus Ijj. I told you that how to write the that coding part, right, where M2 is equal to IRjj, M1 is equal to ISjj. Therefore, equation 8 can be evaluated for Jj is equal to 1 to Ln. I just told you for Jj is equal to 1 to Ln, this thing only, right, where Ln is equal to number of branches, that is Ln is equal to, here I have written that is Nb minus 1. Now, you have to compute the now current through branch 1 to 7, because you have this diagram you have 7 branches 1, 2, 3, 4, 5, 6, 7. Now, what is I1? You apply Kirchhoff's first law. I1 is equal to this I2, whatever the current going to the load, I2 plus I3 plus I4 plus I5 plus I6 plus I7 plus I8. This is, you just apply Kirchhoff's first law. So, I1 is equal to the current through branch 1 to up to 7 branches are there. So, I1 is equal to, when I am writing here I am putting suffix, I am not putting in bracket, but when I will see the mathematics I will put them in bracket, but they are same, there should not be any sort of confusion, right. So, I1 is equal to I2 plus I3 plus I4 plus I5 plus I6 plus I7 plus I8. That means, this I2, I3, I4 all we have to compute, will come next step, right, will come later. So, this is the equation 11. Similarly, the branch current I2, this is your I2, I2 is equal to actually I3 plus I4 plus I5 plus I6 plus I7 plus I8, because this is the current I2 entering into this, entering here. So, this current will basically it is going here only, this current, right. So, Kirchhoff's first law again. So, I2 will be I3 plus I4 plus I5 plus I6 plus I7 plus, this is equation 12. Everything I have made it here such that you should understand this, right. Then I3, this is the branch current, I3 is equal to I4 plus I5 plus I6 plus I7 plus I8, again Kirchhoff's first law. So, it is I4 plus I5 plus I6 plus I7, this is equation 13 say. Similarly, branch 4 current, it will be I5 plus I6 plus I7 plus I8, it is I4 is equal to I5 plus I6 plus I7 plus I8, this is equation 14, right. Similarly, current through branch 5, that means current through branch 5, I5, this one, it will be I6 plus I7 plus I8. So, I5 is equal to your, it is I6 plus I7 plus I8, this is equation 15. Similarly, I6 is equal to the current through branch 6, it will be I7 plus I8, Kirchhoff's first law only, right. But I am not writing I6 is equal to I7 plus your what you call your this small I6 also is equal to your small I7 plus capital I7. Here also I1 is equal to capital I2 plus small I2, but again I2 is equal to, if you write I3 plus capital I3, ultimately it will be sum of all these currents, right. So, what our objective is that branch current can be represented by the load current, but I am not writing I1 is equal to I2 plus capital I2 plus small I2, do not do that, then you have to write many more equations. So, only this load current, right, because this current will be all these things. So, but if you again put I2 is equal to I3 plus I3, ultimately you will find I1 is equal to your I2 plus I3 plus I5 up to summation of I8, right. So, do not do that. So, similarly, I6 is equal to your I7 plus I8, this load current, ultimately this current is this current. You can say I7 plus capital I7, but capital I7 will be small I8, ultimately I7 plus I8, same is applicable here. So, do not consider this, I1 means all this current, Kirchhoff's law I1 is equal to capital I1 is equal to capital I2 plus small I2, again you will try to put this way, but directly you can put this, ultimately it will be same, right. That is why all these things are made. So, similarly, capital I7, that is the last one, that is it is equal to small I, because this is the current actually going to the load, because no other branches beyond that, right. So, it is I8. So, and in terms of power it is given PL2 plus, because this data will be known, right. So, these are all branch current mathematics, I mean simple thing, very simple thing. This last one is equation 17. Now, therefore, if we know the nodes beyond all branches, it is possible to compute all the branch current. That means, this table, if you know all these nodes beyond all branches, then automatically branch 1 current can be computed, That means if branch 1, beyond branch 1, these are the node 2, 3, 4, 5, 6, 7, 8. Therefore, capital I1 is equal to, it is small I2 plus I3 plus I4 plus I5 plus I6 plus I7 plus I8. If you know beyond branch 2 all these your nodes, then it will be capital I2, the current will be small I3 plus small I4 plus small I5 plus small I6 plus small I7 plus small I8, whatever we have just seen. Similarly, all these things capital I7 will be is equal to actually your small I8, right, sending and receiving, and this way you have moved, right. That is why you have written capital I7 is equal to small I8. That means, that is why this necessary, that nodes beyond branches, this is necessary. You have to make this table, you have to read this data, and similarly, but no variable is given. Why not given? I will come later how we have given this, right. And similarly total number of nodes, this one you have to make it, right. So, question is that this here I have kept blank. When I will explain, at that time I will put something here, at that time things will be understandable, right. So, now the load currents of load currents of your node 2. So, look, this is the node where voltage V2, this is the V2, and this is the load connected PL2 plus JQL2, and I2 is the current going through the load. So, you know now from load flow studies in general, P minus JQ is equal to V conjugate I. This we have studied in our power system analysis load flow studies. Therefore, you can write PL2 minus this, when you put in mathematics, PL2 minus JQL2 is equal to V2 conjugate into I2. That is why we are writing here. We are not putting any this thing what you call this one I am putting in bracket, but this one here I have not put it in bracket, but later I have made it, right. Later I have made it. So, what we have done it, later I will give you, it is generalized thing is given. I2 is equal to this one PL2 and your QL2, that suffix 2 and with bracket 2 all are same, but here I did not put in bracket. Later I have generalized, at that time I put them in bracket. So, I2 is equal to PL2 minus JQL2 upon V2 conjugate. Voltage also I am putting them in bracket, right. If you want, you can make it in bracket, no problem, but I have not done it. So, I3 is equal to PL3 minus JQL3 V3 conjugate. That means, here your this load is connected to that node 3, V3 is the voltage and I3 is the current. Therefore, I3 is equal to PL3 minus JQL3 upon V3 conjugate. This is equation 19. Similarly, your all I4, I5, I6, I7, I8 all you can compute. That means I4 is equal to PL4 minus JQL4 upon V4 conjugate, I5 is equal to PL5 minus JQL5 upon V5 conjugate, I6 is equal to PL6 minus JQL6 upon V6 conjugate, and all equation numbers are given. I7 is equal to PL7 minus JQL7 upon V7 conjugate, and I8 is equal to PL8 minus JQL8 V8 conjugate. Now, if you want here also, this one also you can put in bracket, right. If I want to say this is my I2, this is my I3 in bracket, say all are in bracket, say this is I4, this is I5, this is I6, instead of suffix I am putting in bracket, actually it is say I6, right. This is your I7, this is your I8, right. You can put it like this. That means in general that means I2, I3, I4, I5, I6, I7, I8 all can be computed. How will it be computed? Because you have to know, because PL, QL known, but V2, V3 all are not known. So, load flow studies you know that your flat voltage start. So, for V2, V3 whatever is the slack bus voltage, for all these initial values of V2, V3, V4, all these voltages will be your considered as a slack bus voltage initial one, such that initial values of I2, I3 all can be computed. We will come to that, right. Therefore, the load current of say node P, it can be written as IP, again I am writing PLP minus JQLP upon your V conjugate P in bracket. So, this one also if you want you can put it in bracket, no problem, right here, but anyway for general thing it is P is equal to 238, because it is at currents are at 234. So, here I am writing IP is equal to PLP minus JQLP upon V conjugate P, where P is equal to 238. If you put P is equal to 2, you will get I2 values. If you get P is equal to 3, but initial values are known, right. Now, question is that again I have made this table. You have to just understand, very easy actually, very easy, right. Now, branch number j j 1, 2, 3, 4, 5, 6, 7, right. There are 7 branches, and nodes beyond branches, all these things are given in the table, right. In this table it is given, all these things are given, all these things are given. So, just rewriting all this sending and receiving and not putting in the table 2, right. Only these nodes I am putting, or these nodes I am putting. So, these are the nodes are given, and total number of nodes here given, total number of nodes n j j beyond branch j j, it is given 7, 6, 5, 4, 3, 2, 1 in this case. That means, when j j is equal to 1, n 1 is equal to 7, when j j is equal to 2, n 2 is equal to 6, when j j is equal to 3, n 3 is 5, and so on. That is why here I am writing n 1 is equal to 7, n 2 is equal to 6, n 3 is equal to 5, n 4 is equal to 4, n 5 is equal to 3, n 6 is equal to 2, and n 7 is equal to 1. That means, this thing we are putting again in better form, that this one only. This one and this one same, this one and this one they are same, right, and this is the branch number and this is the branch number, right. So, this way we are putting that this is my n 1, n 2, n 3. I hope this is understandable, right. Next one is, now we have to define a matrix E j j k. That means, there that nodes beyond branch j j, you have to store this in a matrix, right. So, here nodes beyond branch j j is given, but this whole matrix you have to store in a matrix form, because you have to read the data in a computer. So, what you have to do is, Newton-Raphson, so many things we have seen in algorithm, right. So, here this data you have to store in a computer. So, you have to put this in an array, in a matrix form, that will be better. So, what we define? We define a matrix, say E is equal to, sorry, matrix E j j k, right. This is the matrix, say E j j k, where j j is the branch number and k will vary from 1 to up to n j j, right. That means, this thing, this whole thing actually is a matrix, it is in the form, this whole thing is a matrix. Here also this whole thing you put in a matrix, right. Here if we write that thing, that will be actually E bracket j j k, right. This is the whole thing we are putting in a matrix. So, here also it whole thing actually E j j k, this whole thing will put in a matrix, it will be E j j k. Here I am not writing, but here it is actually E j j k, this way you have to move, but how to take it, how to put it in an array, right. What you will do is, this all this total number is given, nodes beyond branch j j is given, right. But let me tell you, identification of nodes beyond all branches, algorithm is there, identification node and identification of branches beyond all branch j j, identification algorithm is there, right. But I am not here, we do not want to make that your identification algorithm. Just if you have the single line diagram of network, you can prepare the data and you can easily get the solution by reading this data, but this node also can be identified by identification algorithm. But that algorithm I thought in the classroom purpose better not to discuss. So, this thing I have made it of my own, that how to give the data such that your things will be easier, right. So, identification algorithm is there, but question is that we are not showing it here, just we will see that put this data in an array and see that how things can be computed. So, for example, this matrix, that means whole data we are keeping in a matrix E j j k. So, this is actually given, j j is branch number and k is equal to 1 to n j j. For example, when j j is equal to 1, n j j is equal to n 1 is equal to 7, because this is the total nodes, n j j is the total node beyond branch j j. So, you have for j is equal to 1, n 1 is 7, because here you have 7 nodes, you mark those 7 nodes, right. Therefore, why I have taken this E j j k matrix, because if you in that case, if lateral branches will be there, so same matrix E j j k will be used and automatically data will be read, right. So, for example, when j j is equal to 1, then n j j is equal to n 1 is equal to 7, and therefore, k is equal to 1 to n j j, that means k is equal to 1 to up to n 1 or k is equal to 1 to up to 7, right. That means, that when j j is equal to 1, it is E 1 1, E 1 2, E 1 3, E 1 5, E 1 6, E 1 7. That means, your E 1 1 read this data, you have to read it, E 1 1 is equal to 2, So, when j j is equal to 1, u1 is 2, then u12 is equal to 3, u12 is equal to 3, then u13 is equal to 4, then u13 is equal to 4, then u14 is equal to 5. This is the fourth element, u14 is equal to 5. Is the fifth element, u15 is equal to 6. This is given. Then this is your sixth element, u16 is equal to 7, u16 is equal to 7. The seventh element, u17 is equal to 8. So, this is that for your u11, u12 up to u17, because k is varying from 1 to up to nj, and j you are changing, right, j you are changing, and that means this for j j is equal to 1, these are the elements, these are the data you have to read in the computer. Rather than identification algorithm, you will find these things quite easier, right. When j j is equal to 2, that is n j j is equal to n to 2 is 6. That means here if there are 6 numbers, so n 2 is equal to 6, right. Therefore, when j j is equal to 2 means it will be e 2 1, because j j is equal to 2, your matrix is your e j j k. So, when j j is equal to 2, n 2 is 6, right, because n j j is equal to n 2 is 6, and k is varying 1 2 up to n 2, or n 2 is equal to 6, 1 2 up to 6, and j j is equal to 2, because your matrix is j j k, right. So, you can write e 2 1 is equal to 3. So, e 2 1 is equal to 3, the second row here. Then e 2 2 is equal to 4, e 2 2 is equal to 4. Then your e 2 3 is equal to 5. Therefore, e 2 3 is equal to 5. Then your e 2 your what you call e 2 4 is equal to 6. E 2 4, this is the fourth element 6. Then e 2 5 is 7. E 2 5 it is your what you call, it is 7. E 2 5 is equal to 7, and then your e 2 6 is equal to 8. E 2 6 is equal to 8. These elements first to identify and read this in the computer, all this data e11 your e matrix, you have to read this data in the computer. So, similarly e 2 5 7, e 2 6 8. Thank you very much, we will be back.